So we have students. We have learned, dear students. We have learned about bow and skewness. Now we will study about needle cutting and yarn severance. Needle cutting or yarn severance. Severance means cutting. So needle cutting or yarn severance is a condition. So before that, I want to revise what I have told you in the last class. Bow and skewness are two properties which if appeared will be treated as bad quality fabrics and garments. So bow is the condition where filling yarns are displaced from a line perpendicular to the selvage and form one or more arcs across the width of the fabric. Skewness is a fabric condition results when filling yarns are angularly displaced from a line perpendicular to the edge or side of the fabric. So that is about bow and skewness. Needle cutting, yarn severance. Needle cutting or yarn severance is a condition in a fabric where needle has cut yarns rather than displacing them during sewing operations. This can be due to blunt needle or improperly sized needle. Needle cutting or yarn severance in a fabric is objectionable because it may result in reduced seam strength or poor appearance or both due to frayed yarns. For needle cutting or yarn severance testing, sewn seams are prepared, unless seams are taken from previously sewn garments. The sewing threads are removed from the test specimens. The count of the number of fabric yarns and the count of the number of severed and fused fabric yarns in the direction most nearly perpendicular to the direction of sewing are used to calculate the needle cutting index. Needle cutting percentage is equal to number of yarns cut per centimeter divided by number of yarns in fabric per centimeter into 100. So for needle cutting or yarn severance testing, sewn seams are prepared unless seams are taken from previously sewn garments. The sewing threads are removed from the test specimens. The count of the number of fabric yarns and the count of the number of fabric yarns and the number of severed and fused fabric yarns in the direction most nearly perpendicular to the direction of sewing are used to calculate the needle cutting index. Needle cutting index percentage is equal to number of yarns cut per centimeter divided by number of yarns in fabric per centimeter into 100. It is customary to take at least 3 to 5 specimens to test, and the final test result is expressed as an average of the test results of these specimens in terms of the needle cutting index. So needle cutting is a phenomenon in which needle, instead of sewing, it has cut the yarn and because of this cutting, why is it cut like that? Because it is a blunt needle or improperly sized needle, and because of this needle cutting happens, and needle cutting index is there. Needle cutting index percentage is equal to number of yarns cut per centimeter divided by number of yarns in fabric per centimeter into 100. Next one is sewability of fabrics. 5.10 Sewability of fabrics. Sewability is that characteristic of a fabric that allows it to be seamed at the full limit of high speed sewing machinery without the fabric suffering mechanical degradation. Sewability is that characteristic of a fabric that allows it to be seamed at the full limit of high speed sewing machinery without the fabric suffering mechanical degradation. Experience has demonstrated that the strength of many woven fabrics is considerably reduced by the seaming operations. The result of such reduction is the shortening of the overall life of a garment. This loss in fabric strength and poor seam appearance are usually due to the cutting, scorching, or fusing of fabric yarns by a sewing needle. The loss in fabric strength and poor seam appearance are usually due to the cutting, scorching, or fusing of fabric yarns by a sewing needle. In a survey of apparel manufacturers, fabric sewability was mentioned as one of the top 10 quality problems by small, medium, and large manufacturers alike. The sewability of a fabric or the degree of its resistance to needle damage can be determined in two ways. One measure of this property is the proportion of fabric yarns cut by the needle. This method was crossed under needle cutting, discussed under needle cutting and yarn severance. Another measure of this property is the loss in fabric strength caused by needle damage. Another measure of this property is the loss in fabric strength caused by the needle damage. The measurement of the loss in fabric strength due to needle damage consists of sewing a seam in the fabric, breaking the fabric at the line of stitching, and establishing a ratio between the original and seamed fabric strength. It is generally considered that if the seam efficiency falls below 80%, the fabric has been excessively damaged by the sewing operation. Seam efficiency is equal to seamed fabric strength divided by original fabric strength into 100. So, seam efficiency is very simple. After seaming, the fabric strength is found out and original fabric strength is measured, and the percentage of that is seam efficiency. It is customary to take at least, so it is the same thing, five specimens. Needle cutting yarn severance occurs due to the stiffness of the fabric yarns and a lack of mobility of the yarns. Instead of moving and or deforming when the needle penetrates the fabric structure, the yarns remain taut and are ruptured or burned. Some damage may result from the excessive heat generated due to the friction of the sewing needle and the fabric. Also, using wrong size needle will result in sewing damage. So sewability of the fabric is one of the top 10 qualities of the garment, which should be, if we should not form a defect, because if sewability is not there, then the garment cannot be sewn properly. and needle cutting should not happen. And color fastness, now we are coming to color fastness. So I will just check if we have anything on needle cutting and yarn severance. So we don't have anything generally, so this is a regular topic. So color fastness, we have color fastness. I won't read it completely because color fastness is a simple thing you can read on your own self. And color fastness to washing, that is one thing. Color fastness to dry cleaning, color fastness to light, color fastness to crocking, crock meter. What is the crocking thing? Crocking means the color transfer from fabric to the other fabric or other surfaces. Color fastness to perspiration, color fastness to abrasion, color fastness to heat, color fastness to burnt gas fumes, color fastness to ozone, color fastness to bleaching, color fastness to water, color fastness to chlorinated pool, color fastness to water spotting. So that is about color fastness. So there are so many topics, so all of them are very simple. So now we will come to 5.12, dimensional changes in apparel due to laundering, dry cleaning, steaming and pressing. So for your sake I will read one thing. Color fastness to heat, I will read this. Okay, I'll just read and explain. So color fastness, we have almost 10 to 14 topics. In that I will read one. Color fastness to heat, hard pressing. Sometimes a garment seems to change its shade or color after pressing. Sometimes that happen because some dyes do change shade when exposed to heat, such as while ironing or pressing. Many dispersed dyes, since they have no strong ionic groups, exhibit a significant vapor pressure and when exposed to sufficient heat will transform from a solid to a gas without passing through a liquid phase. If a fabric dyed with dispersed dye is exposed to high temperature, the dye may sublime and the dye vapor may be absorbed by adjacent fibers. This becomes a problem if the adjacent yarns or fibers are white or a contrasting color. On the other hand, the dye may simply sublime and change its original color. For some dyes, staining occurs due to poor non-vapor or contact transfer. Such dyes melt at temperature much lower than the temperature at which they sublime, and therefore on exposure to high temperatures they pass through a liquid phase. Such behavior of dispersed dyes can cause end-use problems in hot pressing, wet pressing and storage. In this test method, the test specimen is subjected to dry pressing, damp pressing and wet pressing in presence of an undyed fabric, which is 100% cotton, desized and bleached, 80 into 80 print cloth. Any color change in specimen or color transfer on undyed fabric are evaluated in comparison with grayscale for color change and chromatic transference scale for color transfer. We have to take 5 samples. So AATCC test method 133. So this is, till now we have studied ASTM standards, but this is AATCC, American Association of Textile Chemists and Colorists. Test method 133 is the test procedure. It contains the step procedure. So this is about color fastness. Color fastness, it is very simple. The effect of change in color, that's it. Transfer of color, that is color fastness. If the color don't change, then color fastness is good. So coming to dimensional 5.12, dimensional changes in apparel due to laundering, dry cleaning, steaming and pressing. So I will, if I don't press it, it will go. So consumers consider the dimensional change in a garment to be a critical performance characteristic. The excessive shrinkage or expansion of a garment can make that item unwearable. So the excessive shrinkage or expansion of a garment can make that item unwearable. Color loss or change may make a garment unacceptable, but it does not necessarily make it unusable. Holes and tears might be repaired and frequently can be anticipated by judging the quality of fabric. Dimensional change is hidden from the consumer until it is too late. Garment shrinkage due to laundering, dry cleaning, steaming and pressing occurs at 3 levels: fabric, yarn and fiber. The total observed shrinkage is the resultant shrinkage at these 3 levels. The contribution of each to the total depends on both the fabric and yarn structure, as well as the nature of fiber. For example, cotton fabric may shrink as much as 10% under conditions that cause only 2% shrinkage in the component fibers and yarns. In cotton fabrics in general, shrinkage occurs principally at the fabric level. So, it is for this reason that cotton fabrics are successfully pre-shrunk by a mechanical process known as sanforizing. It is for this reason that cotton fabrics are successfully pre-shrunk by a mechanical process known as sanforizing. Rayon fabrics, on the other hand, exhibit most of their shrinkage at the fiber and yarn levels. For this reason, sanforizing is not effective on rayon fabrics. Fiber and yarn shrinkage is minimized by the same process that is used to obtain better crease resistance. Resin treatment. Resin treatment. So shrinkage is one of the aesthetic properties. So if it shrinks, if a fabric shrinks after one or two washes or one or two dry cleanings, then it is not useful for use, and it is not comfortable sometimes for the consumer to use again and again, and therefore that will mar the market of the product. So garment shrinkage, so cotton shrinks a lot, whereas other fabrics, other fibers shrink only 2%. Cotton shrinks 10%. So shrinkage may occur at fiber level, yarn level, or fabric level. So the shrinkage may be ascribed to one or more of the following four distinct factors: relaxation, swelling, felting, contraction. So we have four topics to discuss. So listen carefully. It has been well established that fabric shrinkage may be ascribed to one or more of the following four distinct factors. So fabric shrinkage may occur because of the following four, one or more. First one is relaxation, second one is swelling, third one is felting, fourth one is contraction. Relaxation. When yarns are woven into a fabric, they are subjected to considerable tension. When yarns are woven into fabric, they are subjected to considerable tension, particularly in the warp direction, although the filling yarns are also stretched. In the subsequent tendering and calendaring operations, this stretch may be further increased and temporarily set in the fabric. The fabric is then in a state of dimensional instability, and when it is wetted thoroughly, yarns contract and try to regain pre-stretch level. The contraction in the filling direction is normally considerably less than in the warp direction, although in some fabrics it can be high enough to cause complaint unless steps are taken to contract it. This is called relaxation shrinkage. So when yarns are woven into a fabric, they are subjected to considerable tension, particularly in the warp direction, although the weft yarns are also stretched. In the subsequent tendering and calendaring operations, this stretch may be further increased and temporarily set in the fabric. The fabric is then in a state of dimensional instability. And when it is wetted thoroughly, yarns counteract and try to regain pre-stretch level. The contraction in the filling direction is normally considerably less than in the warp direction, although in some fabrics it can be high enough to cause complaint unless steps are taken to contract. This is called relaxation shrinkage. So, yarns contract, filling yarns contracting to regain to the pre-stretch level, which is generally less, but when it is problematic, then it is called relaxation shrinkage. Swelling. Shrinkage that results from the swelling and deswelling of fibers because of the absorption and desorption of water is called swelling shrinkage. In a loosely woven fabric, the effect of this swelling of the fibers is greater than in a tightly woven fabric because there is greater freedom of movement in a loosely woven fabric. Swelling. Shrinkage that results from the swelling and deswelling of fibers because of the absorption and desorption of water is called swelling shrinkage. So, because of water's absorption and desorption, the fibers swell and deswell, and because of this shrinkage occurs. This is known as swelling shrinkage. In a loosely woven fabric, the effect of the swelling of the fibers is greater than in a tightly woven fabric because there is greater freedom of movement in a loosely woven fabric. So that is swelling shrinkage. Next, felting. Shrinkage that result primarily from the frictional properties of the component fibers which cause them to migrate within the fabric structure is called felting shrinkage. This is normally considered to be significant only for fibers having scales on their surface such as wool. So felting is a word that is coined for wool. So the wool fibers have scales on their surface. So shrinkage frictional properties of the component fibers. Because of the frictional properties, the component fibers may migrate within the fabric. This is called felting shrinkage. Contraction. Contraction means decrease in length. If it is original length is 10 centimeters and if it is reduced to 8 centimeters, then it is contracted by 2 centimeters. This is the decrease in length that takes place in synthetic yarns fabrics when they are exposed to temperatures higher than 21 degrees Celsius. The tendency of synthetic fabrics toward contraction shrinkage can almost be eliminated by heat setting the yarns. synthetic yarns. So by heat setting the contraction can be avoided. Synthetic yarns that are not heat set before or after they are converted into a fabric will shrink due to steaming and or pressing during apparel manufacturing. So heat setting is done so that contraction does not occur. Shrinkage of a garment can occur when it goes through one or more of the following processes. Process on the left hand side, type of shrinkage on the right hand side. So I am reading one left, one right. Laundering, mostly relaxation and swelling, felt, felting in case of wool fibers. Dry cleaning, same as above. Steaming, contraction in case of synthetic fabrics. Pressing, same as above. There are 6 test methods, 5 AATCC test methods, and 1 ASTM test method for evaluating the dimensional changes in fabrics and garments as follows. So, I will read all these things. AATCC test method 96, 99, 135, 150, 158, and D2724. So these are the 6 tests of dimensional changes. So the principle in all the 6 test methods is that fabric specimens are marked 25 centimeter and 25 centimeter. The maximum distance that can be marked in both length and width with indelible ink, washing or dry cleaning these specimens, once drying them, conditioning them, then measuring the distance between those marks and calculating shrinkage in terms of percentage. So shrinkage percentage is calculated by these methods. Sometimes these specimens are washed and dry cleaned 2 or more times, then shrinkage is measured after 3 dry cleaning cycles. Shrinkage is sometimes measured after 5 laundering or dry cleaning cycles. While most of the garment fabric shrinkage will occur in the first laundering or dry cleaning, shrinkage may occur in several subsequent launderings or dry cleaning, which is called progressive shrinkage. That is why some companies make it a practice to measure shrinkage after 3 to 5 launderings or dry cleanings. So progressive shrinkage is while the fabric is in use over 3 months or over 2 months or over 1 month, how much shrinkage has happened. So that is the one. Some garment manufacturers, knowing that the fabric will shrink excessively in laundering, will make the garment oversized, particularly in length, will make an allowance for fabric shrinkage. Therefore, considerable judgment must be exercised before deciding that shrinkage test results for a particular garment are unacceptable. Should garments be made oversized to allow for an excessive fabric shrinkage, then the manufacturer would be wise to advise consumers to wash that garment first before wearing. Such information can be conveyed on the hang tag. So, dear students, we have completed fabric thickness in the last class. Today's class, in the last class we have covered fabric thickness and skewness, bow and skewness, and today we have in this class we have covered needle cutting, yarn severance, and in the needle cutting yarn severance we have studied needle cutting index percentage, which is equal to number of yarns cut per centimeter divided by number of yarns in fabric per centimeter into 100, and 5.10 is sewability of fabrics. So sewability of fabrics is depends on seam efficiency. Minimum seam efficiency should be say 80%. If it falls below 80%, then that is not commendable. So, and seam efficiency is equal to seamed fabric strength divided by original fabric strength into 100. So color fastness, we have color fastness to washing or laundering, that is one. Color fastness to dry cleaning. Next, color fastness to light. Color fastness to cracking. Color fastness to perspiration. Color fastness to abrasion. Color fastness to heat. Color fastness to burnt gas fumes. Color fastness to ozone. Color fastness to bleaching. Color fastness to water. Color fastness to water spotting. After that we have studied dimensional changes in apparel due to laundering, dry cleaning, steaming and pressing. So dimensional changes do occur in a fabric after laundering and dry cleaning and steaming and pressing, and why this occurs. And sanforizing is a mechanical process which is done on cotton, and cotton shrinks very high percentage to a very high percentage, 10 percentage, almost 10 to 8 percentage, 8 to 10 percentage. And so sanforizing is a pre-shrunk mechanical process for cotton. Rayon fabrics cannot be sanforized and it is not effective on rayon. Fabric shrinkage may be ascribed to, ascribed to one or more of the following four distinct factors. Relaxation. First one is relaxation, next one is swelling, next one is felting, and then contraction, and then after that, so in these four topics, relaxation, shrinkage and swelling shrinkage. So swelling shrinkage is a phenomenon observed in cotton because it swells when the water is absorbed, and it may dissolve water also, and then in deswelling occurs, and because of this swelling occurs. Felting is a shrinkage that is observed in wool where the fibers in the wool migrate within the fabric So this is known as felting shrinkage. Contraction is decrease in length from original length to some 2 percentage length is reduced, then it is known as contraction. And we have 5 test methods, 6 test methods: AATCC method, test method 96, 99, 135, 150, 158. These are AATCC test methods. And D2724 is the ASTM standard test method for testing dimensional changes. So these are, so far we have studied all these things, so that is enough for now. So we have completed dimensional changes in fabric.